So today our standard is 8.EE.8a, analyze and solve pairs of simultaneous linear equations. And our essential statement is I can solve systems of equations by graphing. So there are three different ways to solve systems of equations, and the first one is by graphing. It is considered to be one of the easier ways to solve systems, so that's what we will be starting with. And since we just reviewed graphing lines, this shouldn't be too difficult. So we will go ahead and start with some vocabulary. So a system of linear equations consists of two or more linear equations that have the same variables. So you will be solving for x, and now you will be solving for y, and you will have two equations in one problem. And to get a solution to that system with two variables, it's any ordered pair that satisfies all of the equations. So you will get an x equals and you will get a y equals, and what you will need to do is write it as an ordered pair, x comma y. So getting down to our first example, this is how I normally write a system. I have this sort of squiggly looking line over here. This just lets me know that these two equations are part of one system. So here we have y is equal to negative 2x plus 6 and y is equal to x plus 3. Find the solution to this system. So I know my answer is going to have an x equals and a y equals. And because we're solving the systems by graphing, guess what we're going to do? We're going to graph both of these equations on one coordinate plane. So here we have our coordinate plane. I'm going to go ahead and open this up. All right, here we have our coordinate plane. Now, it doesn't matter if you use different colors, but I will go ahead and do so. So I will start with my first. Oh, and if you need to pause the video at any time to draw something or write something out, feel free to do so. Okay, that's what videos are for. So our first equation is y is equal to negative 2x plus 6. Here our y-intercept is positive 6, so I will go ahead and 1, 2, 3, 4, 5, 6. Oh, oops, I didn't make my graph long enough. And my slope is the number in front of x, which is negative 2. So I will go ahead and go down 2, 1, 2, and I will go over 1. It's rise over run. So I will go down 2 and over 1. Then I'm going to take my ruler or my straight edge or my protractor, and I'm going to go ahead and connect my lines. And go ahead and make your line through the entire graph. This is super, super important. And next I have y is equal to x plus 3. So I'll go ahead and start at positive 3. And my slope is the number in front of x, which there is no number, which automatically makes it a slope of 1. So I go up 1 and over 1. Oh, they share a dot. That's okay. That happens. I will take my straight edge and connect, okay, the dots, make my line go through my entire graph. And here we have something like this, okay? We have two lines that intersect each other. Now, your solution to this system is two numbers, x and a y, that satisfy the equations. And guess what? It's where they intersect. So when you're solving a system by graphing, wherever your two lines intersect is what your quote-unquote answer is, where your solution is. So in this case, our answer, okay, is right there. So what is that point? And you have to think about back to when we were reading points and plotting points. So let me go ahead and open that up. My answer or my solution is x comma y. In this case, the x is 1 and the y is 4. So yes, x equals 1 and y equals 4. However, you have to write that as an ordered pair. So therefore, my answer is 1 comma 4 with parentheses around it. So this is very important, what I just opened up. When the lines intersect, there is one solution. You have two things in that solution, but there's only one solution. All right, moving on. So let's go ahead and get started oops, with our next example. So here's our next system. Y is equal to negative 2 over 3x plus 4, and y is equal to negative 2 over 3x. So those arrows just mean those are the colors I'm using, so don't worry about that. Negative 2 over 3x plus 4. So I'm going to go ahead and start at positive 4. 1, 2, 3, 4. I'm going to make my dot. And then I have a slope of negative 2 over 3x. So I'm going to go down 2, 1, 2, and over 3, 1, 2, 3. I'm going to make my point. I'm going to take my straight edge and connect the dots. And then my second line says y is equal to negative 2 over 3x. There is no visible y-intercept. And when there is no visible y-intercept, you start at the origin, you start at 0. And then my slope is also negative 2 over 3. So I'm going to go 1, 2, and 1, 2, 3 over. 2 points make a line. I'm going kind of fast through plotting of the points because we've done it so many times. All right. Uh-oh. What do we see? I just told you in the previous examples, where your lines intersect is where your solution is. So what happens when your lines do not intersect? Well, if your lines do not intersect, you do not have a solution. So therefore, when the slope is the same, so I wonder if anybody caught that up here, okay? When the slope is the same, the lines are parallel. Thus, they will never intersect. So therefore, there is no solution. And the last thing I wanted to show you is this, okay? When the linear equations are exactly the same, that means you have a line, and then you have a second line that falls right on top of this line. Therefore, your lines touch at every single point on this line. And when they intersect at every single point on that line, that means your solution is everything. So you have infinitely many solutions. Again, feel free to pause at any point. So a quick review of what we just learned about systems by graphing. The first thing is when you graph your lines and your lines intersect at a certain point, that point gives you one solution. If you graph your lines and your lines do not intersect, which means you have the same slope, therefore you have no solution. And then if you graph your lines and your line is exactly the same and it falls on the same line, you have infinitely many solutions. So there's 3 possibilities all in all. If you have any questions, please feel free to let me know and I will help you in any way that I can.